So before we talk about BLAS scoring system, since we will be using a lot of discussions about p-values and e-values, so let's take a detour and see what these p-values are. So in order to understand those p-values or probability values, let's look into the normal distributions one more time. A normal or Gaussian distribution is a continuous probability distribution, so commonly it is observed as a bell-shaped curve. It's bell-shaped, symmetric around the mean, so as many values to the right of the mean as to the left, and theoretically it goes from negative infinity to positive infinity. And in an ideal scenario, this distribution has a mean of 0 and standard deviation of 1, so we commonly call it as a Z distribution. So generally it's represented as like this. So most of the distributions are the distribution of numbers in nature around us, weights, heights, number of leaves on the tree, many other examples which we can quote over here. So they are distributed like this. If we plot them, if we take the frequency of different individuals in each and different classes, we can come up with a curve like this. So that thing is the shape of the distribution. So it looks like a bell. So we have all the values under this, the whole populations. So this is called as Z is standardized value, or we can have a Z score related to this distribution, which is given by this formula. So we have Z is equal to Y for any observation, which is Y, and this is our mu, our grand mean, and this is our standard deviation. So Z is given by this formula. And as far as the curve is concerned, so that has a mean of 0 and standard deviation of 1. So if we have a perfect distribution like this, we call it as a Z distribution or Z score. So every distribution can be represented as with the help of the Z score. So we have some means in nature and we can present them, or we can calculate the Z score for those means. So in this way, if we take this normal curve, so we have Z values which are coming from negative 2 to positive 2 as far as this example is concerned, but we say that they are from negative infinity to positive infinity or just infinity. Then if we look into this curve, we can come up with a probability distribution also. So the values under these curves, they have some probabilities which are associated with it. Value over here, probability of finding them towards this side is small, some small numbers like this, and it keeps on increasing if we start moving towards this side. So the probability of finding any number over here is 50% or 0.5, and over here up to that point is 1. So probabilities, you know, they range from 0 to 1. So what is p-value? P-value is the probability of finding some event or some value under this curve. So if we correlate them with the Z score, so Z score of -2 can have a probability of 0.02. So it is present in, we can say, lower 2%. So anything below that, Z score of -2, below that can be present in this region. Same way, if we want to get those top 5% or 10% or 20% or whatever is it, we can check on this tail. So here are the values which are, say, top 10%, somewhere here, where we can have our p-value that is equal to 0.9. So it can come, say, for example, over here. Same way for a Z score of 2, we can have the value 0.98. So here are upper 2% of the values. So normally when we get those values and we plot them under the curve, we are interested in finding the significant events or the extreme values, those values which may be weird, so weird that we can try to say that they are significant or they are important. So in this case, if we are interested in, for example, upper 2% of the values, they are right here. So any values whose probability is in upper 2% are greater than 0.98, so we call them as significant events. Here less than 0.02, these are significant events. So these things, we observe some events and we come up with some Z scores and we try to get the probability of those Z scores. So let's elaborate that with another curve. So here these p-values or probability of finding those values, since they are cumulative, we can come up with some numbers, say for example -6 to +6. So here you can find that event as a whole, so your probability is 1, and these probabilities over here in this curve, they are cumulative, so we keep on adding the probabilities coming from the previous. And if you go from left tail and start moving towards right, so your probability keeps on increasing. So if you are here, everything below this, since you have covered your curve 100%, so probability of finding everything is maximum. This kind of arrangement is called as sigmoid. We'll talk about that later. So here we can do that in an example. So for example, you have a mean of a distribution that is equal to 85, standard deviation is 10, and you are looking for a number, whether it is present on top, for example 5% or less than that. So is that a significant number or not? So here our question is, for example, what is the probability of some y less than 100, probability up to that point? So we can calculate its z-score first with this equation. When we plug in our equations, the values in that equation, our z becomes 1.5. So this goes where it goes in the curve. So we have z values and we have those mean of this distribution as 85, and below that I have written it this z in order to tell you that z of 1 is also can be taken as if something which is towards the right 1 standard deviation away from the mean. Z of 2 is 2 standard away from the mean on the right hand side. Same way -2, z-score of -2 is 2 standard deviation below the mean. So we take that value 1.5 guys, and we want to see, is it significant event or it's not significant event, or what is the probability of seeing this number 1.5. So we see that the actual number was 100, z-score was 1.5. so when we get into the probability tables for z, we have those tables, or we can use Microsoft Excel to get those values or the p-values. We see that it is present at 0.9332. So probability of observing this number is 0.9332. Is it present in, if we look around from other side, is it present in top 5%? So this is present somewhere here, that is less than, not in top 5%, but in maybe in some, say we can say top 7%. So whether is it a significant event, and that's interesting to find out. That depends upon your requirement. So for example, here we say that anything which is present in top 5% is significant. So this may be a non-significant event, but we see that probability of finding a number up to 100, anything less than 100 stays here. So 93% it will be there under the curve. We can use different Excel functions to get that probability. Norm as start test, if we have a z-score and we put it true, that is if we are getting its a cumulative value. So cumulative is probability up to that point, which is 0.9332. That's what we want, so we put it as true. So it will give us the p-value for that, which is 0.93. You can try it in Excel. We can have a probability, we can put the probability, we can put the mean and standard deviation, and in this way we can get the z. This 1.5 we can get it with norm dot inverse. If you want to solve this whole equation for z, there is a function called norm dot dist. So we give the number 100 and then we give the mean and standard deviation and let the cumulative as true. So that will give us this 1.5. This function will return the probability. It will not give you just z, but it will go further and give you the p of that z also. So your answer will be 0.9332. So sometimes if you have the probability, you want to work back and see what the z value was over there. So for that you can use this function. So in this section we try to just emphasize one point. So what is the p-value? So p-value is the probability of finding some value under a curve. It can be a standard normal curve as a case of z distributions, or it can be some other distributions which are fitting to your data.